In this video, we will practice solving trig equations, such as these and others. In part, your ability to solve these equations will rely on the fact that you have memorized certain facts. You should be able to generate a chart like this one in a couple of minutes. Okay, sometimes it's as simple as getting the trig function by itself. So, for example, in this case, if I want to get sine squared x by itself, I need to add 2 to both sides. And so that's going to give me 4 sine squared x is equal to 2. Continuing to isolate, I need to divide both sides by 4. So that's going to give me sine squared x is equal to 1/2. Now, to get sine x by itself, I need to take the square root of both sides. Okay, so that's going to give me that the sine of x is equal to plus or minus 1 over the square root of 2. I just did the square root of 1 and the square root of 2, but the square root of 1 is 1, that's why it's just a 1. So now, we can analyze this and ask ourselves, what angle will make this true? Well, ignore the plus or minus for just a moment. The sine of what angle is 1 over radical 2, which, by the way, is the same thing as radical 2 over 2. Let's look back at the chart, though we should have this memorized. Okay, you see the 1 over radical 2 right here. So the sine of pi over 4 is 1 over radical 2. Well, that tells us that the reference angle is pi over 4. So we should draw ourselves a little diagram of a unit circle showing pi over 4. Okay, so these are pi over 2 so far. If I'm going to split them again. Okay, so now this is pi over 4. Each one of these is pi over 4. Now, the reference angle of pi over 4 occurs in 4 places: here, 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 and here. Each one of these 4 angles has a reference angle of pi over 4. That means the sine of any of these 4 angles is going to give us some kind of 1 over radical 2. 2 of them will be positive 1 over radical 2, and 2 of them will be negative. And because sine is a y value, these 2 angles will give us a positive 1 over radical 2, and these 2 angles will give us a negative. Now, because we're looking for angles that will give us positive or negative 1 over radical 2, we're going to keep all 4 of these angles. So all 4 of these angles will be the solution. If we only had positive, we would just take these 2 angles. If we only wanted negative, we would take these 2. But since we want plus or minus, we're going to take all 4. Okay, so what are these 4 angles? Well, the first one is simply pi over 4. Okay, x equals pi over 4. Or the second one, so this is 1 pi over 4, 2 pi over 4, 3 pi over 4. So the next one is 3 pi over 4. 4 pi over 4, 5 pi over 4. 6 pi over 4, 7 pi over 4. All right, so these are the 4 solutions to problem number 1. Now, I'm not going to do this for all of these or even other problems that we're going to do, but I feel like I should mention checking of your answers as a way of showing what we mean by the fact that these are solutions. If these are solutions, that means any of these, if we substitute them back into the original equation, it should make a true statement. And in this case, that means all of this left side should equal 0. So I'm just going to randomly pick one of these. Let's say 5 pi over 4. Let's check that. So if I wanted to check the value of x equals 5 pi over 4, that would mean, let's plug it back in. So this would be 4 times the sine squared of 5 pi over 4. Okay, minus 2, and we're trying to see if that equals 0. Okay, so 4. Now remember, sine squared theta means we're doing the sine of this and then squaring it. So what is the sine of 5 pi over 4? Well, of course, the reference angle is pi over 4. So let's start with that. What's the sine of pi over 4? Well, we know that that is 1 over radical 2. Okay, so this is either going to be positive or negative, depending on the quadrant. So 5 pi over 4, that is this one down here, so that's going to be negative. Okay, so the sine of 5 pi over 4 is negative 1 over radical 2. And since it's sine squared, that's why I'm squaring it. So far, this is what we have. Now, if I square this, order of operations, you square things before you multiply. Okay, so if I square this, squaring something that's negative is going to make it become positive. And then 1 squared is still 1. Radical 2 squared is just going to be 2. Radical 2 times radical 2 is just 2. So this becomes positive 1/2. Now I multiply it. 4 times a half, or a half of 4 is 2. So then I get 2 minus 2, which does equal 0. So it works. Something similar would happen no matter which one of these 4 things you plugged in. In fact, because they all have a reference angle of pi over 4, again, all of these have a sign of either 1 over radical 2 or negative 1 over radical 2. So regardless of whether this is positive or negative, once you square it, it's going to become 1/2 in all 4 of these cases. And you're going to get the same result. Let me mention one more thing. In reality, if we went around and around the unit circle, there are infinitely many solutions to this equation as we go around more times. But we are limiting ourselves to answers between 0 and 2 pi. So we're limiting ourselves to 1 revolution around the unit circle. All right, looking at problem number 2. Our first job is to get the trig function by itself. So we would add 1 to both sides like this. That would give us 2 sine x is equal to 1. Then we would divide both sides by 2, like this. All right, that will give us sine x is equal to 1/2. So now we ask ourselves, all right, the sine of what angle is going to equal 1/2? Okay, and we've memorized this. The sine of pi over 6 is 1/2, so we should have that memorized. Okay, but that just tells us the reference angle. That's not the only answer. Okay, so right now we know that the reference angle is pi over 6. But we should use that fact to draw ourselves a diagram. Okay, so here's the diagram. Here's pi. Okay, now I'm going to divide this pi into 6 pieces. So I'm going to go like this. Okay, so I have 6 pieces in the top, so these are pi over 6s. So there are 4 angles that have a reference angle of pi over 6, and here they are. All 4 of these angles are going to have a sine of either 1/2 or negative 1/2. 2 of them will be positive, 2 of them will be negative. Because sine is a y value on the unit circle, then these 2 will be positive and these 2 will be negative. All right, so since we want the value to be positive 1/2, we're going to pick these 2 angles at the top. Okay, so we can forget about the negative ones. So the answers will come from this and this. Now, what are they? All right, so this first one is in fact the pi over 6, the reference angle itself. Okay, so x is equal to pi over 6. But that's not the only answer. This angle over here is also going to be a valid solution. And that is, so this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Okay, so 5 pi over 6 is the other solution. All right? So most of these equations are going to have at least 2 solutions. All right, number 3 is going to be a little bit more complicated. I see like terms that we have here. We have sine x on both sides of the equation. So I'm going to have to deal with that. So I think I will add sine x to both sides of the equation like this. All right, sine x, sine x. Sine x plus sine x is 2 sine x. So now I have 2 sine x plus radical 2 equals 0 because these cancel out. I still now need to get sine x by itself. So I would subtract radical 2 from both sides. So that will give me 2 sine x is equal to negative radical 2. To get sine x by itself now, I need to divide both sides by 2, like this. So that's going to give me sine x is equal to negative radical 2 over 2. So this is the point where I ask myself, for what angle is this true? Sine of what angle is negative radical 2 over 2? So ignore the negative sign for a minute to ask yourself what the reference angle is. All right, so the sine of what angle is radical 2 over 2? Now you should have memorized this. The reference angle then is pi over 4 because the sine of pi over 4 is radical 2 over 2. All right, you can see that on the chart. Sine of pi over 4 is radical 2 over 2. Now, that's just the reference angle. That's not the answer, to say nothing of the fact that we really want negative radical 2 over 2. But let's start with the fact that we now know the reference angle. So once you know the reference angle, you can draw the correct diagram. All right, so I'm going to draw a diagram of pi over 4s. Okay, so I split the top half into 4 pieces, and I have pi over 4. So now reference angles. You're going to always have 4 angles on the unit circle that have the same reference angle. All right, the 2 right above the x-axis and the 2 right below the x-axis. So these are the 4 angles that have a reference angle of pi over 4. Every one of these will have a sine of either radical 2 over 2 or negative radical 2 over 2. And because sine is a y value, then these 2 will be positive up above the x-axis, and these 2 will be the negative radical 2 over 2. Now in this case, we want the negative radical 2 over 2, so the solutions are going to be these 2 angles here. Okay, so what are these angles? Okay, so here we go. So x is equal to. So this first one, this is 1, 2, 3, 4, 5 pi over 4. Okay, 6, 7 pi over 4. All right, so these are the two solutions to number 3. Okay, how about number 4? Again, I see cosine on both sides. Those like terms must be gathered together. So I'm going to subtract 2 cosine x from both sides. Okay, so those cancel each other out. But on the left side, now I have 2 cosine x is equal to 1. In order to get cosine x by itself, I'm going to divide both sides by 2. So that will leave me with cosine x is equal to 1/2. Now, what is the reference angle? All right, the cosine of what angle is equal to 1/2? The reference angle is pi over 3. I'm getting that from the chart. Okay, cosine of pi over 3 is 1/2. So it's essential that you be able to generate a chart like this one so you can do what I just did. All right, so the cosine of pi over 3 is 1/2. Now that just tells me the reference angle. Okay, because the reference angle is pi over 3, I'm going to draw myself a chart of pi over 3. So I'm going to take pi and divide it up into 3 pieces. Okay, so these are pi over 3's now. So here are the 4 angles that have a reference angle of pi over 3. All of these will give me some kind of 1/2, the cosine of any of these, but 2 will be positive and 2 will be negative. Because cosine is the x value on the unit circle, then these 2 on the right will be positive, where x values are positive, and these 2 on the left will be negative. Since we want the cosine to be positive 1/2, then these 2 angles will be the solutions. Okay, so x equals. Okay, so the angle pi over 3 itself is the first solution. But then we also have this one. All right, so this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So these are the 2 solutions. Okay, let's keep going. Okay, looking at number 5. We have this extra 3 in here. The big thing to remember is you cannot divide by 3 to take a 3 from the inside.